Okay, good afternoon, everyone. Welcome to the 12th workshop organized by PolyU. We are delighted to have Professor Wilson Liu as our guest speaker this afternoon. Before I introduce Professor Liu, let me give you a very brief introduction about our project. This particular project is funded by the Professional Service Advancement Support Scheme of the Hong Kong SAR government. The project itself is aiming to improve and export Hong Kong industrialized construction service under the Belt and Road Initiative. This is a project sponsored also by the Hong Kong Construction Association and supported by the RICS. The aim of the project is to enhance the competitiveness of the construction industry in Hong Kong, to facilitate integration of various technologies as well as policies in industrialized construction, and encourage multidisciplinary collaboration in the provision of construction services. Apart from myself, we have Surveyor Thomas Sear from the Hong Kong Construction Association, also Dr. Justina Yung from PolyU's Belt and Road Liaison Unit as our team members. So this is the rundown for today's workshop. I will give a brief introduction of the speaker, followed by the presentation, and then Q&A, followed by feedback. So let me give a brief introduction to our guest speaker today, Professor Wilson Liu. Wilson is a professor in the Department of Real Estate and Construction in the Faculty of Architecture in the University of Hong Kong. He graduated from PolyU with his PhD back in 2006. I believe he's at least one of the best PhD graduates I have ever known from this department. His research interests include construction management with 3 clear directions, including international construction, construction informatics, and construction waste management. Professor Liu is the author of more than 130 books, book chapters, and journal papers. He has a very impressive Google citation over 5,000 and Edge index over 40. He has been ranked as one of the top 1 scholars by Claret Analytics since 2017. And he is also the recipient of Hong Kong U's Outstanding Young Researcher Award back in 2014-15, and a number of other awards from the university. So without further ado, let me hand over to Professor Wilson Liu. Professor Liu, please.
Thank you, Jeffrey. Thank you, Professor Shen's introduction. It is always a big honor to come back to the department to share with you some research we conduct at Hong Kong U. And today's topic is, can I make it full screen? So today's topic is something like we call the design for X, not for a higher index. So it's for searching an optimal level of prefabrication construction for different socio-economic technical contexts. Actually, I present this, I think, 2 years ago at PolyU, and since then we actually developed this idea into a journal paper, and then we have some further development I would like to share with you. The outline of my presentation is, first I give you some observations, and then the major argument of my presentation. And then, of course, we give some definitions, and then use Hong Kong as a case. Hong Kong's off-site construction, MIC construction, okay, as cases. And then I propose something called design for X. Actually, this is not a new idea, but talking this idea in the construction industry, we feel need some further research and development. And then in the final part, I will talk about the prospects and the challenges. And I don't know whether we can do it in a more interactive way. If it is difficult, then I will save some time for the Q&A. Okay. So I don't know if you have any question. So just feel free to raise in this system. I'll try to answer your question. So this topic is based on some observations. Okay, we observed the governments in different parts of the world are increasingly ambitious to set forth some target of higher level or of prefabrication. So across the world, across the global construction industry, you may have read or heard something different agendas, okay, with regard to prefabrication. Like in the Europe, the UK, offsite, they call it offsite construction. Okay, is worth around 2 to 3 billion British pounds and account around 2% of the total construction market. Okay, in 2009. CIOB report also mentioned some cases in Sweden. For example, 84% of the detached houses use prefabricated timber elements. Okay, I'm not too surprised because in Sweden, the IKEA, okay, they are actually master of Legos and prefabrication. In Germany, you can also see 9% of the new residential building permits are issued for prefabrication buildings. In Netherlands, 20%. And back to Asia, you can see in China, the Beijing government, central government also issued different circulars to try to promote prefabricated construction. So in a technical note, in 2016, it says try to achieve a proportion of 30% of the prefabrication construction in new construction projects. Okay? In about 10 years, they set up a relatively ambitious index of prefabrication construction. Okay? No matter how the 30% is defined, we will talk about this later on. In Hong Kong, so prefabrication is not new, and it has been implemented in public housing since 1980s. The literature often cite a case that in some of the mock-up or pilot projects, okay, prefabrication has been around 65% of the overall construction. So you can see in Hong Kong, we are also promoting kind of high index, although it is not clearly mentioned, but in people's mindset, it sounds okay, that you try to achieve a higher index of prefabrication. It sounds like the higher the better. So you also notice different plans in Singapore. For example, Singapore is even higher in terms of the plan for prefabrication. So, for example, prefabrication level for public sector projects, okay, measured by CFA, has increased from 30% to 50% during 2013 to 2015. So 50% of the GFA was constructed use prefabrication in Japan. So also you can see a very higher level of prefabrication in Malaysia. They are adopting some like industrialized building system. They have their own scores, but it seems they are also trying to promote a higher index of prefabrication. These are the governments, the practitioners, the industries, academia is also joining to advocate a higher level of prefabrication. So we did some brief literature review, and we can spot in different papers, different publications, okay, authors try to promote a high level of prefabrication. It seems that a prefabrication race, okay, we often heard about war race, okay, but it sounds like a prefabrication race is on the rise, okay, across the global construction industry. That is the observation, okay, I want to highlight with you. My argument is prefabrication level is not the higher the better. Okay? I want to refute, I want to attack this prefabrication race. Okay? I want to argue prefabrication level is not the higher the better. There should be some optimal level of prefabrication suitable to a certain socio-economic technical context. Okay? So you have different countries, different economies with different socio-economical background, with different technical capacity, with different policy institutional arrangement. So for a certain context, there must be an optimal level of prefabrication. So now the issue is how to search such an optimal level of prefabrication. Okay, so I present this in a graphical manner. So this is more like an indicative. On the horizontal axis, you have different levels of prefabrication. I will elaborate a bit more. And then on the vertical part is the performance. Okay, you have different level of performance. Okay. I will define a bit more about the performance later on. Definitions. You probably have heard different definitions related to prefabrication. Okay? Now, actually, the terminology is becoming rather complicated. For example, you probably have heard of prefabrication, precast. Okay, in Hong Kong, in the Great Bay Area, in Pearl River Delta. Okay, this precast is also very popular. And then the latest, okay, the heated term in Hong Kong is MIC, modular integrated construction. You read literature, you must have heard about off-site construction, and some other researchers, practitioners may also mention industrialization. So what on earth are these terms? Okay, so I try to provide some definitions. They are not necessarily the only definition, but just some of the definitions. So, for example, precast, it is a construction product. Mostly is a concrete, okay, produced by casting concrete in a mold or in a form, and then cured in a controlled environment, okay, and then transport to construction site and lifted into place. So it's more like a construction product, like a slab, like a facade, and some partition wall, and some even more complicated or volumetric precast products. And prefabrication. Prefabrication is the practice of prefabrication. Okay, precast is a precast. Prefabrication is the process of assembly components of a structure in a factory or other manufacturing site, and then transport the complete assemblies, or actually a part of the assemblies, to the construction site where the structure is ultimately located. Okay, MIC is a kind of definition used in Hong Kong, is a construction method, so comprising the freestanding integrated units. Okay, again, it's manufactured in a factory environment, and then logistic to, and then installed on a site to form a building. Okay, the difference is these units are pre-assembled with finishes, furniture, fittings, so reduce some work in situ. You must have heard about offsite. Actually, offsite is very popular nowadays. So particularly preferred by Professor Gibb from Loughborough University. Offsite construction refers to structures or components of a building or of a structure built at a different location. It is not on-site, it's off-site, different locations other than the local of the use. Okay? It could be individual modules of the buildings are constructed in a factory in the Pearl River Delta and then transport to the site for assembly to a final building in Hong Kong. Okay? Off-site, I think this is contrasting with on-site, and then industrialization. Okay? So includes the extensive use of prefabricated, factory finished, large-sized elements, and the conversion of the product into a mechanized and a continuous flow. I think this is a major shift from traditional projects to products and then manufactured in an industrialized way. Okay? So I hope you are still with me. So after I present some of the concepts, what I want to point out is actually these ideas are not mutually exclusive with each other. Okay? They are just emphasized on different aspects. Okay? For example, offsite. Very often people equate offsite construction as prefabrication. Actually, prefabrication can also be on-site. Okay? Have you ever encountered some on-site prefabrication? Actually, for some infrastructure projects like a road, okay, like express railway, because the site is very long, and sometimes you have the space to cast some of the components on site, pre-cast the components on site, and then hoist and install to the site. Actually, that is prefabrication, but it's on site. So don't equate off-site construction with prefabrication. Okay? There are some on-site construction as well. So prefabrication, precast, okay, could be pointing to the same thing. Okay, prefabrication or precast could be organized in an industrialization way. Okay, industrialized way. MIC is also a certain way of prefabrication. You prefabricate, okay, the units, okay, off-site, or sometimes you prefabricate something on-site. So you understand the different concepts, okay? And then they just emphasize on the different aspects. Okay? So industrialization normally involves precast or prefabrication. It could be off-site, but it could be offshore, but it could be on-site in one day. Actually, later on, I will show you some other cases. Okay, this is on-site prefabrication. Now, we come to we look at after we understand the definitions, we look at the prefabrication level. Okay, so actually there are different researchers trying to define different prefabrication level. For example, these also I cannot pronounce his name properly. In 2000, can be measured by the ratio of value of the work done. So, for example, the whole building is 1 billion. Okay, a certain value, a certain ratio of the value is done by prefabrication. So people can use that as an index, as a level of prefabrication. Also could be the CFA. Also could be the even the weight of the precast, and then on-site concrete, for example. And Sira and Zamora in 2013, they define different levels, like a basic level, OP0, like a completely work on-site. That is a cast in situ. So we probably know we've set up some formwork and force work, and then cast concrete in, and then wait for its curation, and then dismantle the formwork and force work. So that's a very traditional cast in situ, and even nowadays, this is still popular. Disregard that concrete has been arguably invented by Italian for 2,000 years already, and then you have an initial level, you have advanced level, and the integral level. There's some other researcher, Steinhardt, in 2014 also defined the levels 1 to 5. My favorite one, also perhaps this is also the most widely adopted one about prefabrication level, is the GIP, okay, proposed in 1999. So GIP developed a level system of prefabrication in building. There are 4 levels. The first one, actually, there are 5 levels. The 0 level is the casting institute we mentioned, and then level 1 is component and sub-assembly. GIP also gives some examples, like lintels. And then level 2 is a long volumetric assembly. So like 2-dimensional precast concrete wall panels, okay? Like foundational walls or some wall panels or floor slabs. Okay? So that is a precast components with no usage space enclosed. It's 2D, okay? So no usable space was enclosed in this level 2. And then level 3 is called the volumetric assembly. So you have some components, actually some of the units, like the bathroom, kitchens, okay, it's volumetric. So you have different hinges, different connection points. So the difference with this level 3 is you have some usable space enclosed already, like a bathroom. It's basically enclosed, although there's no sink, no toilet or some other things. Okay, and then level 4 is the modular building with 3D modules and with some utilities installed already. So in my presentation, I actually adopt GIP's definition. Okay, levels 1 to 4, levels 0 to 4. But you are encouraged to to remember that actually there are some other definitions about prefabrication level. Some use the GFA, some use the CFA, or some use the volume of materials like the cubic, or even the IBS, or even the weight, okay, of the materials. Actually, there's a rule of thumb formula for you to convert the volume of materials and the weight of the materials, or even the value of the materials. Now, performance, okay, horizontal bar, performance. So obviously, performance means different things to different people. So it's a multi-faceted concept. Okay, you can examine this from productivity, buildability, manufacturability, assembly, sustainability, cost, maintenance, recycle, reuse. All these aspects can be considered as performance. So now my argument is like you have different levels of prefabrication. You can refer to Gibbs' definition, and then actually to different contexts, a socio-economical and a technical context, different level of prefabrication. Actually, you have different performance. So it's not necessarily the higher, okay, like level 4 must be the best for this context. Okay, so it is important for a certain context to search for an optimal level of prefabrication, so as to achieve the optimal performance or best performance. Okay, I want to share with you the prefabrication industry here in Hong Kong. And some very exciting cases in Hong Kong. So these two pie charts shows you the supply of housing units in Hong Kong. So if you look at the left-hand side, by the end of March 2012, okay, in Hong Kong, we basically we have three types of housing units. One is the private flats, high-end. Normally, it's very expensive. Okay, Hong Kong is now perhaps the most expensive place on the earth in terms of housing price. So you can see around 56% of all the units, private flats, all the housing units in Hong Kong, around 56%, okay, is private flats. Okay, and then another 44% of the units are actually public housing. So in terms of public housing, again, Hong Kong, we have two big categories. One is called PRH, public rental housing. So around 30% of all the units are PRH units. And then around 15% are subsidized housings. Okay? So these are for the so-called sandwich class. Okay? So your income is not high enough to afford the private flats, but your income is higher than some other class, so you are not eligible for public rental. So for this sandwich class, we call it sandwich class, the government actually produced some subsidized units for them to purchase. Okay, this is the pattern for 2012. And if you look at the right-hand side, so 2018, 6 years later, you can see roughly the distribution, the proportions are the same. Okay, over the years. The government and the private sector, they have endeavored to increase the supply of the units, but basically the pattern is the same. So a quick one is around half of the population in Hong Kong are living in all sorts of public housing, okay, either public rental housing or subsidized housing, home ownership scheme, okay, or some other type of subsidized housing. I heard in Singapore this number is around in 40%, but in Singapore the public housing is supposed in a better condition. They call it 主屋, 主屋. So we actually prefabrication has been widely used in public housing. Okay? As I say, the 44% of the units are public housing. So actually, the public housing programs start from 1952 or some in the 1950s, early 1950s. In fact, long history in Hong Kong, and the different generations of prefabricated housing has been developed, and some of them are becoming internet sensations now. So I have never been to these two places, but in the future, if you come to Hong Kong, you do spend some time with it. It's a very popular place for taking photos and post on your blog or something. So in the public housing programs, prefabrication has been widely used in these programs. And nowadays, prefabrication in public housing, actually in private sector, has evolved into a very clever model. I show you this in this diagram. For example, it is basically designed in Hong Kong, okay, like a public housing authority. They have their own design team because it's a constant client, so they have their own in-house design team. And then the manufacturing is actually taking place in the Pearl River Delta or the Greater Bay Area, because 10 years ago, 15 years ago, in Pearl River Delta in mainland China, they have a wider space, they have bigger space for placing, is to arrange the product lines, to placing the products and semi-products for transportation. And then these components, there are also some cheap labor and cheaper materials there, although we adopt a British standard. So it's designed in Hong Kong, but the procurement and some other standards, manufacturer standard, actually Hong Kong's a standard. And then these components are transported back to Hong Kong across the border. So, you know, there's a one country, two system there. So we still have customs. So you need to clear the custom clearance. And then you sometimes you place some of the components in a storage, like a Kwaichong, or sometimes if you are more ambitious, you try to achieve a just-in-time delivery and then assemble the components on site when it arrives, when a component arrives. So that's we call it offshore. It's not only off-site. Okay, it's not only off the construction site, but also offshore to mainland China. So I would say this arrangement is actually a very clever way, okay? Because Hong Kong, we have constraints. We don't have enough space to set up the factories or precast the yards, and then the labor and then also the materials are all more expensive there here. Although these kind of dynamics are changing a certain degree. Okay, so if you look at these cross-border offshore prefabrication, you can see the different stakeholders involved in different places, different process. So over the past years, actually, I visited most of the prefabrication factories supplying Hong Kong. Okay? They are mainly in Pearl River Delta. I visited factories with some other professor, including Professor Jeffrey Shen. Actually, in 2014, we come to apply for a research grant called IFID Enable BIM for prefabrication housing production in Hong Kong. So the topic is a prefabrication. Okay? Prefabrication is mainly using in housing projects, mainly used by the public sector, but nowadays private sector are also using prefabrication. So this kind of logistic and supply chain is becoming very sophisticated. And then we try to develop a platform using RFID, the auto ID technology, and the BIM to try to enhance logistics and supply chain for this process. So we compare the prefabrication. Like we probably know that Cast Institute has some pros and cons. Also, actually, prefabrication has some pros and cons. Like a Cast Institute safety site record is rather poor in Hong Kong. Around 25 construction workers were killed every year on site. Okay, so by all sorts of accidents. 25 is fatality is not really acceptable. And then you have inadequate trained workforce. And Hong Kong, the average age of construction workers is now exceeding 50. So youngsters doesn't want to join this industry. And then we actually suffered from labor shortage. Environment performance, if you look at the diagram, the photo there, the site is actually very untidy. Sometimes you have water, seepage, all sorts of environmental issues. And you use extensive use of traditional methods like formwork and force work, bar bending, cutting, concreting, curing, that kind of traditional methods. It's rather labor intensive. The productivity is declining, and the building cost is higher. But of course, Cast Institute, as I mentioned earlier a little bit, Cast Institute is still very much popular, either in mainland China or in Hong Kong, because it has its own strengths, unfortunately, like flexibility and interesting here. You have a lot of design changes actually throughout the construction process. Design is changing all the way, and the Cast Institute is more accommodating to these design changes. Okay, people believe that Cast Institute, the product is more stiff, can resist the typhoon better, and also the seepage issue can be solved in Cast Institute. But of course, you also heard a lot of reported benefits of prefabrication. For example, it's a faster. So later on, I'll show you in Hong Kong U case. While you are doing the foundation work, actually you can do the production work of the units in China, or so you can actually doing some jobs in parallel rather than following the traditional sequential way. Okay, you do the foundation first, and then you do superstructure following that. Quality is better, so you are supposed in a factory environment, and it's cleaner, so it's a product line, it's a factory. It's supposed to be safer, so because increasing workforce on site, particularly Hong Kong site, is very tall, falling from the height or hit by the materials or some other machinery, actually the major causes of death. Okay? or injury in Hong Kong. So like now you do this in a factory environment, it can decrease the occupational and health safety issues. Whether it is cheaper, actually, interestingly, prefabrication in Hong Kong is more expensive. And some researchers report like 2% of the cost increase. Perhaps because of high setting up cost, and then some other issues like of economy of scale, and then the transportation cost is higher, and then you require a lot of hoisting power. So actually, last time in a project, pilot project, there was a kind of a external wall, a single piece of precast external wall is as weight as 7.5 tons. Okay, to hoist the piece of precast component, you actually need some extra hoisting power. So different, actually, the strengths and the weaknesses of Cast Institute and prefabrication, okay, have been touched upon in different literature already. As I mentioned, although off-site construction or offshore construction, you have different benefits, but actually there are also some shortcomings. So some of they still prefer the traditional Cast Institute construction. Therefore, the government, Hong Kong government, and its government departments actually devised the different institutional arrangement to encourage prefabrication. For example, in 2001, I guess, the government departments, including buildings department, lands department, and planning department, these departments issued a joint practice note, actually joint practice notes 1 and 2. So in the JPNS, they said that you building developers, you could receive GFA exemptions if you adopt some green building technologies, including prefabrication. That's a big incentive. That's a big incentive. Okay, so developer, I see that prefabrication is more expensive. It's a bit inconvenient, but now the government issued the incentive that I can have some GFA exemptions if I adopt prefabrication. Actually, that's the carrot given by the government. I must say this incentive has been abused a little bit. So developers, they just make use of the and then try to increase their GFA exemptions. So it went too much far. So in 10 years after the joint practice notes were issued, the government issued some new joint practice notes. Okay, the main point is to cap the overall GFA exemptions to 10%. So no matter what green features you use, now it's capped 10%. It's still very encouraging. So in Hong Kong, basically, the government wants to promote something. I think the most welcoming incentive by the private sector is this kind of GFA exemption, because now a developer, you can sell your real estate projects with more GFA. That's money, given housing is so expensive in Hong Kong. I remember when the government was promoting, it's still promoting BIM, Building Information Modeling. A lot of developers try to lobby the government, okay, to have some more GFA exemption, but government was very cautious about GFA exemption until recently. The government now is promoting MIC, so they issued another circular. It's called this time I think it's only one department. This one is a exemption again for GFA for building adopts MIC. Now government is promoting MIC. So the major point is you can have 6% of the MIC floor area for new building. Actually, yesterday I invited two top MIC experts to give a talk yesterday, and they mentioned, indeed, when you use MIC, because you need to increase the wall, partition wall, and some other things. So the thickness of the walls, and then the reduce of the GFA is around 3 to 4%. But after you deduct the 3 to 4% increase of the wasted GFA, you still have 2 to 3%, 2 to 3% of GFA. That's a big incentive as well. So offshore prefabrication in Hong Kong. So some of the photos were shot by us. Some of the photos we found on the internet. These are the major prefabrication precast components used in Hong Kong. So the first one, A, you can see is a precast facade. So interesting, you notice that some of the windows, actually some of the washing bench, some of the sinks were pre-installed as well. So in terms of a facade, this is now quite high level of prefabrication, but still it's not volumetric. If you look at the B, I think that is a volumetric bathroom. So you have a 3D enclosure in there. C is precast staircase, and the D is lower level of precast slabs. So actually semi precast, and then you actually can put some another layer of concrete on it. This is the system that we developed for with Hong Kong. We just mentioned we developed an RFID platform, RFID the BIM platform for better managing logistic and the supply chain for the public housing, because now the components are precast in Pearl River Delta and then transport back to Hong Kong, cross the border. Actually, Housing Authority fund a project, a public housing project for us. So we developed the platform, we test the system. So these are some screenshots of the platform. So if you look at the up left hand side, you can see actually the tie beams, the beams of a commercial center are all labeled with some of our embedded technologies, and all the position from Pearl River Delta to Hong Kong is actually traced, okay? Or whether it has been manufactured, whether it has been on the way to Hong Kong, or whether it has been installed. It's all indicate clearly on the BIM platform. Okay, we steal this from the housings. So in Hong Kong, for a typical layer floor of public housing, they use a 6-day cycle. That means they use 6 days to build the central core, to build the core, and then install the components into the position, okay, in 6 days. That's the prefabrication. Okay, you can see in Hong Kong, Housing Authority has adopted different levels of prefabrication: volumetric kitchen, volumetric bathroom, staircase, facade, slab, and some other things. But now the latest, most popular thing is the MIC, modular integrated construction. So I give you some of the definitions early on. So freestanding, okay, these are not with a 3D freestanding volumetric modules, but with some prefabricated and pre-finished components. Okay, some of the furnitures, some of the beds, some of the things have been installed in the modules already, okay, all off-site in a controlled environment. So in Hong Kong, we have reinforced concrete modular units. This slide I stole from the speakers yesterday. The reinforced concrete modular units. Okay, concrete is relatively cheaper, but the cones is deadly heavy. So it's very heavy. Particularly, I mentioned external wall. Okay, in the project is a 7.5 ton, but for this unit, modular unit, okay, it's exceeding like 10 tons or even heavier. So it's really something. Okay, and also some other typical is a steel frame modular units. You have the steel frame. Then it's more expensive. Like a steel structure is more expensive, but the advantage is lighter than the concrete modular. And in Hong Kong, developers and the clients are very clever. They can do some hybrid modular units. So like you can steel frame, but then cast with some other concrete. So making it's relatively, they struck a balance between the price and then the technicals and also the weight. You need to consider the design aspects like repetitive units. You need to think about the layout of the site. You have to consider the statutory, okay? And then you have to incorporate all these considerations into a design. And the site locations. And also now the size are bigger, so traffic impacts are also an issue. Delivery route. So you have some components in Foshan, in Dongguan and somewhere. So deliver them. Now these are bigger units. Okay? How to plan the delivery route is really something, an issue you need to consider. And then the lifting power, so adequate site space for modular units. Lift operation. I actually guide a group of Swedish experts to our Hong Kong Housing Authority to visit them, and then because you know in Sweden they are also quite strong in prefabrication, although they have they use a lot of wood structure, okay, because of some buildings. A particular point mentioned by the practitioners in Hong Kong is the lifting power is still an issue as seen by them. So by considering all these constraints or the parameters of a setting, like in Hong Kong, okay, you need to. I actually decompose all these considerations into 4 aspects, like political, economical, social, and technical aspects. For example, in political, you need to consider the policies, GFA exemptions, standards, British standard, and a code, guidelines, statutory requirements. This actually is critical. These are very critical for the adoption of different level of prefabrication. Either it's a precast or volumetric or the MIC. Okay. Economic considerations. You need to consider supply. Actually, when Hong Kong tried to adopt this MIC, clients and main contractors, they actually search around. There's no contractor in Hong Kong. There's no one in Hong Kong who is able to supply the MIC. So then they have to go to mainland China. Mainland China is very good. You have a whole spectrum for materials supplied, but then different companies, you still have different capacity to do this schedule. Okay, so Ivan, do we need to take a break or something? Okay, welcome back. I appreciate even in a Saturday afternoon, you are still with us to listen to my talk. And so far we mentioned the arguments, and then we try to talk about the prefabrication and also MIC in Hong Kong. So the argument is that either you adopt prefabrication, cast in situ, or MIC, you need to consider different conditions in the context. Okay, we decompose the conditions into PEST, so political, like standard codes, and then also supplies schedules. Okay, if all the contractors, all the clients subscribe to this MIC, perhaps you have to wait for a longer time because the suppliers are limited. And then you also need to consider the type and the scope of your projects. Like if a high-end office, type A office, perhaps you need to consider some other technologies, whether there's repetitive components like the innovation tower in PolyU. I don't think that is amenable to prefabrication. You also need to consider the socio-technical conditions like labor shortage, labor expertise, and also social attitude. So very often, okay, people treat prefabrication as cheap or lower quality products. Actually, recently, a student of mine, we actually wrote a paper to try to refute that prefabrication doesn't mean necessarily cheap and dull design. User acceptance. So as mentioned, some people will say this is a lower quality and soundproof, some other things, different social considerations. Sometimes it's true, sometimes it's just an attitude. And then you need to consider technical conditions, resources, familiarities. I mean, even so far, there are only a few contractors and clients are familiar with. Cannot say it's familiar. They have a certain degree of knowledge of MIC. Construction tolerance, site logistics. Again, we studied last time a small site in Jiangguan or TKO. It's a very small site for public subsidized housing. And then there's only one space in the ground floor area. All sorts of logistics actually compete that space. So you have to consider your site logistics cleverly, and then form a good strategies to deal with this. Also for MIC, we have some other considerations. So for different considerations, we just try to give a score to different levels of prefabrication in terms of casting institute, in terms of components and sub-assembly, in terms of long volumetric or volumetric assembly, in terms of MIC. Okay, we check all the PEST conditions against Hong Kong's conditions, Hong Kong's context, and then we scored in this way. Okay, we use 2+, for example, to indicate a higher score. 1+ means relatively higher score, and then 0 means neutral, or minus means is a score very lower. For example, we look at volumetric assembly or modular integrated building. You can notice in Hong Kong now the political or the policy side are very encouraging the L3, level 3 and level 4. So by having all these, we have a total score, and then we plot a total score in a 2D coordinations. You can note we derive this figure B on the right-hand side. So this is for Hong Kong. So the result is that Hong Kong is currently between level 2 and level 3. Hong Kong, I must say, is not really ready for MIC. That's my argument. And the performance, if it is level 2 and level 3, I would say the performance is a stay in an optimal status. Okay, this is a case study about Hong Kong. But if you put it into a general setting, I will say, so it is not necessarily the higher the prefabrication level, the better. Okay, it's only a suitable level to a certain PEST context. Actually, I'm not really against Hong Kong's government's MIC, although as a scholar we can say express our professional opinions. So like if you look at the supply, like the expertise, like the arrangement, all these things, we are not really in the best condition to embrace this modular integrated design. But it doesn't mean, okay, we should sit here and wait for all the conditions ready for MIC. Okay? But we are working towards the high level if it can bring the true value to the. So by having this argument, actually, we are also working with the government to look at statutory requirements, economic conditions, and social conditions, and also solving some technical problems. So we are working towards a better setting, a better context for modular integrated construction. But now it's not really ready. So my argument is not really against the government strategy of promoting MIC, but we should point out that it's not higher the better, and we should work towards a better context for harnessing a higher level of prefabrication. Okay, that's basically my argument. I'm not really against something, against MIC, and arguing something. I also proposed something called design for X. Okay, design for X is not really something new. So you probably have heard a very popular term as a design for DFMIA, right? Design for manufacturing and assembly. Actually, this has been considered in the prefabrication industry in Hong Kong already. So why it comes up with a semi precast slab? Why it comes to a facade with sinks, with windows installed. Okay, why it comes to a volumetric kitchen or bathroom. So it's basically an optimal for manufacturing and also assembly. It also is an optimal level. It's called it's for supply chain optimization. So, for example, if it's too big, okay, if it's too big, you have a problem of route planning and also using your long vehicles to transport things from mainland China to here. Okay, if it's too sizable, you have to consider the supply chain optimization when you do this design. Okay? If it's too, and then in logistics and supply chain management, they have a term called shipping for air. Okay, you try to reduce the air to be shipped from China to here, and also design for waste minimization. Okay? Prefabrication is a way to minimize construction waste already. Construction waste is a big issue in Hong Kong and in many other economies. Design for safety, whether you can improve safety record through some thoughtful design, okay? Design for recycling and disposal, and even design for robotics, to trying to use the power of machine of robotics. So putting all these things together, researchers, actually mainly from the manufacturing industry, they invent this called design for X. Okay, X could be excellence. Okay, design for excellence. Design could be anything. Okay, for X could be anything, not only manufacturing, assembly, but also some other expanding criteria. Okay, performance indicators, safety, robotics, all these things. Actually, in my team, I now consciously recruit PhD students to look at this design for X. Okay, we have published a few papers, and we have some PhD students who are working on this. Like a design for DFMA is very popular, particularly in the UK. Okay, so like we published a paper to examine this in the curtain wall system in Wuhan. I guess this project is in Wuhan. So curtain wall is always difficult. Okay, it always lies on the critical path of a project. So whether it is possible to design the curtain wall in a more optimal way, so it can better for manufacturing, also for assembly. Okay, this a few examples of DFMA, like offshore, not only offsite, right? Now it's also prefabricated in the offshore area. If you look at the Bird Nest project, actually it was also a very typical prefabrication. Okay, the external structure is actually manufactured somewhere in Shanghai, and then prefabricated, and then transport to Beijing, okay, through the sea, okay, Shanghai. Second example is the flagship Apple shop in Central. Okay, clients mentioned to us, actually a single piece of the glass is a really beautiful design. Okay, Apple is using very beautiful design. The single piece of the glass there is 1 million Hong Kong dollars worth. Okay, most of them in this project, at least, I think they are manufactured in Tianjin and then transport to Hong Kong. So how to consider the manufacturing and also the size, the panel, and then later for transportation, for assembly, is something you have to consider, right? So now in design, you not only think about traditional functionalities, aesthetic, and some other things, but you also need to consider the buildability, manufacturing, assembly. Okay, the third project is a Hong Kong U Centennial campus, we use a lot of curtain wall. I heard that the curtain wall was really causing a lot of issues. Quality assurance, compliance check. Okay? Prolong the logistic and supply chain. You transport from the northeast of China, okay, and also in Changsha or in Shanghai to somewhere other than the site. Carbon emission, extended producer responsibility, corporate social responsibilities, all these things you need to consider. Another example we mentioned is recently the DFMA of at the airport sky bridge. Okay, some of the numbers, the facts and figures about the project. Okay, it's also manufactured prefabricated in Zhongshan, Guangdong province, and then precast in somewhere in the airport. In the airport, they are doing a lot of land reclamation for they have some space to do the mock-up and the pre-assembly, and then this huge, massive prefabrication component structure. The structure was transported, okay, 5,000 tons, okay, and then transport to the current site for installation. And in outside Hong Kong, a lot of footbridges are using this. I think in Poly-U, the footbridges, perhaps they use the similar things. You have to consider the manufacturing and the assembly, okay? Supply chain optimization. So over the years, we have spent a lot of time to understand the supply chain in logistics and supply chain for prefabrication housing between the Greater Bay Area. Waste minimization. Myself, I also do some research on construction waste management. So recently we are asking one of my PhD students to look at how prefabrication, how design can help minimize waste. Okay. For your information, in Hong Kong, about 25% of the landfill waste is actually generated by construction, a single industry only. So we have to consider this construction industry in terms of waste management, in terms of reducing the impact to the environment. Also for recycling and disposal, okay? We learn from the manufacturing industry, we learn from Japanese practice, and trying to incorporate all this. Design for safety. Design for safety, we are also interested in this area. Like in Hong Kong, you have a lot of openings. If the openings on different floors are not properly designed out or not properly enclosed, they will cause a lot of safety issues, particularly for falling from the height. So how design can incorporate all these issues to help improve the poor occupational health and safety record in construction. Design for robotics. This actually I copied from Thomas Bock's report to Hong Kong's Construction Industry Council. He came to Hong Kong and did a consultation. Actually interesting. His major proposition is if you want to harness the power of robotics, actually you need to, at the design stage, you need to consider the projects, the design already. For example, if I understand correctly, he actually proposed sometimes in some rooftop or the up level, it's not really rooftop up level, you have some precast components on site, okay, and then use the machinery and robotics to hoist them, to handle them. The report is available online, so if you are interested, you may search and then try to understand this. So anyway, the X here is standing for excellence and standing for expanding aspects. Okay. Traditionally before manufacturing and assembly, but now we expand to the waste management, safety, robotics, and some other aspects. This slide I stole from the speakers yesterday. So in Hong Kong, there is a student residence at Wang Zhou Hang in the Hong Kong Island south part. Okay, Hong Kong that's an iconic project using MIC, modular integrated construction. And so, as I mentioned, actually in Hong Kong, we are not really ready for MIC. So they have had to consider a lot of things in reaching in harnessing the power of MIC. For example, they consider the repetitive units in this Hong Kong U project. I start to involve in this project. So they actually have 1,224 student places, actually units, to be modules, okay, to be produced using MIC. More than 1,000 units. Okay, that can actually have some scale of economy, isn't it? And then compact. So now the design for Hong Kong use is a maxi. The length is 8.4 meter, and then the width is 2.5 meter. Height, if I remember correctly, is a 3.1 meter. So they consider the transportation already. They consider the transportation. So in this design, the length actually is well fit into the lorries, okay, lorry in Hong Kong, and the width also fit into the lorries and also the streets in Hong Kong. If you have been to Hong Kong, you will notice the streets are normally very narrow, very congested. So you cannot have too wide units. Also about the weight, hoisting power. So they use a lot of lightweight design for hoisting, deal with, and then furnished. Okay, beds, windows, desks, or pre-finished. Prospects and challenges. So we are still designing more design for excellence, more excellence. The sky is the limit. So we encourage the designers to think more of the aspects by working with the downstream stakeholders, suppliers, contractors, and then FM managers. Okay. So you have integrated this design, but all you need to consider a trade-off or an optimization between the different aspects. So unlikely you can achieve a design for all the aspects. Like you design good for MA or supply chain, but may not be so good for waste minimization or safety or recycling. Okay, or robotics. Unlikely you can achieve them all. So as usual, you need to strike a balance among these excellent aspects. Amenable institutional arrangement, like in a joint practice notes or the incentive of GFA exemption in the years have encouraged the adoption of prefabrication. And now they change this to suit for the MIC. But even though, as reported, as reflected by practitioners and clients, there are a lot of statutory requirements which are still lagging behind the requirement of MIC. For example, yesterday, the CEO of a main contractor mentioned the installation work actually takes 2 or 3 days, but the building approval work took him 4 to 6 months, 4 to 6 weeks to obtain the building approval from the government. The buildings department, the designated government in Hong Kong, they often play safe. They often abide by the old building ordinance. So the statutory requirements need to be modified, updated to suitable for higher level of prefabrication. Okay. Cross-border business arrangement now in mainland China, also they have some very ambitious prefabrication housing programs, right? So you mentioned they want to achieve 30% of the prefabrication over the next 10 years. However, it is defined, but they also require a lot of factories to change to prefabrication. So now the different clients in different places are actually competing for the production capacity. So how to still make good use of this arrangement? Some other issues, some institutional arrangements you need to consider. So using technology is, of course, in a promising way. It's of prospects. For example, this is a system, RFID and a BIM system we developed. So to tag the prefabrication components with actual higher frequency RFID or some others embedded technologies, and then allow the auto ID technologies to talk to people and talk to the online platform system, can obviously help the logistic and the supply chain and some other aspects. So using technical instruments is also of a lot of prospects. This is a technology developed by us. We are quite ambitious to turn some traditional like components, machinery, and on-site objects into something called smart construction objects. Okay? Smart construction objects. So traditionally, very heavy components, modules now become smart. Okay, they have different smart properties. For example, they have their awareness. Can you imagine a modular, a tie beam now has its own awareness? It can realize where it is. Okay, I'm just coming out from this factory and crossing the border and arriving on the site. I've been installed it. Actually, now using our smart technology, we enabled these components with smart properties like awareness. Now, we only say only a human being, okay, has awareness. Now we enable these components of awareness. Actually, it's not difficult to realize. For example, you use a GPS, and then when the GPS exceed like 100 meter, okay, exceed 100 meter outside of the factory boundary, it can tell, okay, now this is, now I'm out of the factory and on the way to Hong Kong. So when the GPS is falling in a certain degree around the border, okay, it can initiate the custom clearance automatically. It has its own awareness, okay, and also has its autonomy, and it can communicate. The components can communicate with each other, can communicate with human decision makers. Okay, so we define the 3 core properties of a smart construction object, and then of course technically we use different technologies like GPS, like thermal, we like Wi-Fi, we lack different components, geoscope and motion sensors to create all these new properties. Okay, we embed all this in something on the right side. This is called iCore. So we test these new technologies on site. And recently, I'm quite interested in using blockchain. Actually, we are going to secure a research project to look at the cross-border logistic and the supply chain. We still use, traditionally we use BIM, we use iCore, but now we add a new layer of blockchain, okay? Or most of the information, necessary information, to prove the originality of the materials, originality of the components, and positions, status, all these things will be put in a blockchain. So the information cannot be muted, cannot be tempered or changed unless the information is, again, consensus by all the parties. Okay, so blockchain is used as a lower level of distributed database technology. We try to secure all the necessary key information. And also a lot of challenges, okay, prefabrication, or particularly for offshore prefabrications, because now there is kind of a backlash of the globalization, okay, triggered by the optimism in Trump's government and some other governments. So traditionally, very old times, okay, we use our local materials, local labors, but then gradually we source these all resources across different countries, across the One Belt, One Road. And now people are thinking to kind of have de-globalization. Okay? There's a backlash of the globalization, and even accelerate by this COVID-19. For example, normally for Hong Kong's clients, for the components, we often send inspection teams, okay, to mainland China for the quality assurance and some inspections. Actually, these teams are not small, okay, often very expensive. So whether it is possible to use blockchain technology to try to guarantee the information, guarantee the process, like the glass, okay, the glass panel I mentioned, is very expensive. How to ensure this process, the manufacturing process, is up to the standard, okay, and also the components, MIC modulars, okay, are ensured by the, and this is really something we need to solve now. The border between Hong Kong and mainland China is still kind of heavily regulated by. It's a particularly difficult time for this COVID-19. So if you want to send someone to mainland China to do the inspection, they have to quarantine for 14 days there, and then if they return, okay, another 14 days. So how to use technologies, okay, how to use blockchain and some other technologies, inspection technologies, to deal with this backlash, to deal with this COVID-19 is something that's very challenging there. And this is the last slide, also about how to source the materials, resources, and construction expertise, machinery across the Belt, One Road. Okay, I understand this workshop is about One Belt, One Road. Against this backlash of globalization is really something, okay, a challenge to all of us. Okay, so that's basically my presentation, and I'm cautious that I will leave some time for Q&A. Thank you very much.
Thank you very much, Professor Wilson. It was a really very interesting and nice presentation. Now the participant, you are all invited to ask the question from Professor Wilson directly, or you may write in the chat box. At the moment, Professor, you can see that we have seen there are some questions on the chat box. If you can open your
the chat box, is still. Let me see what's. I only saw. Okay.
Sir, if you go a little up, there are a number of questions from Dr. Amos.
Amos, yes. Thank you for the insightful presentation. That CAST Institute is stiffer and easy to handle the issue of typhoon. Considering that typhoon is a critical issue in building in Hong Kong, do you have any idea of how this is being handled in MIC in Hong Kong? Yeah, okay. I'm not an expert of MIC actually, particularly for structural part. In Hong Kong, MIC, we still use the kind of CAST Institute for the main structural part. Like in the Hong Kong use, I don't know, some other project, when it is a low-level project, you just use units and then you couple them with some patent technologies. Yesterday, some people showed me the technologies. But in Hong Kong use projects, when it's a high-rise project, you still use they use a steel structure. Okay, steel structure to ensure that the main structure can resist typhoon. And yeah, actually yesterday some people asked about the earthquake. My reply is earthquake is not really. Hong Kong is kind of a place. Earthquake is not an issue, too much of an issue. Okay. Okay. Yeah.
So if you go a little more down, sir, there are some other queries from Dr. Amos and from the other participants.
Yeah. Can it be that just because Hong Kong is now starting MIC, and that is why the figure shows between levels 2 and 3 exactly? Yes. Perhaps after 2 or 3 years, when I do this again, then the optimal will be levels 3 and 4. Perhaps.
Thank you very much, Prof. Wilson, for the answer to this question. The reason why I asked this question is, for many of the countries, when they MIC, they weren't ready to start it. For instance, when Singapore started 10 years ago in 2010, they mentioned that I went for a course there, and they mentioned that they were not ready because they didn't have the suppliers. They didn't have project managers who were experienced in doing MIC. So they had to go to the UK and other places to learn from them, to get project managers from other countries to do that. Yes. But then they still went ahead to do it, and now they have more experience in PPVC. So I was like, maybe if a similar study can be done in the future for Hong Kong, the results might change, because Hong Kong is just now starting the MIC. So it's very reasonable that you identify that we are not ready for it, and we are still at the level 2 to level 3, because that has been done for some years now.
Yeah, that is a good point. So as I mentioned, that perhaps the 3 to 4 years later, because the government is also trying to change the statutory requirements, and then industries are still in different teams. They are looking at the structural part and then the manufacturing part of MIC. So yeah, after 3 to 4 years, it should be having a good MIC journey. Let's wait and see.
Right. Thank you.
Thank you.
I had another question about where you presented the different aspects of for design for X, and you mentioned design for assembly and manufacturing. I was like, how about design for logistics? Because I always think about this DFMA and I'm like, it is excluding logistics because it's moving from just design to. So how about the logistics? But then I realized you mentioned supply chain management, so maybe the logistics comes in over there.
Yes. So yes, actually, DFMA, I think in the middle, particularly in here, actually for you should consider the logistic and the supply chain. As I mentioned, you don't want to ship air, but also when it's too ambitious, too integrated, perhaps the logistic and the supply chain conditions don't allow, like too wide. Or so you can see the Hong Kong U project, the design. It's very narrow, might be uncomfortable. I don't know, so, but that's the constraint.
Yes, I mean for that project, the site is very restricted, and I don't know how they manage to do the logistics. I read that they are targeting to do JIT, just in time, and I don't know if that is possible, but it's something that I would like to learn more about later if they were able to achieve that.
Yeah.
Looking at a very high site.
Yeah. The good sign is the Hong Kong U Estate Office Director and the main contractor were with me yesterday, so we're going to work on that project.
Okay. Thank you very much.
Okay. Thank you.
So we have another question from Mr. Zishan. If you go down.
So who's? Oh, so a question is Matthew Tang. Would you please introduce more about the uses of MIC in the construction of skyscrapers? I don't really know about this aspect. I don't.
I have a question to ask, Professor.
Yeah.
Yeah, thank you very much for the presentation, particularly regarding Design for X. I very much interested in Design for Excellence too as well, and I've been exploring the literature in the context of building construction. But there's a discrepancy in the literature I want to, confirm and verify with you. There's the emphasis on guidelines. I see some of the researchers in UCL. I think I don't know whether you collaborated in that paper. Particularly DFMA. They're talking about guidelines so much, but when you refer to the manufacturing literature, there has been so much success in the adoption of a systematic procedure. I mean, systematic procedure as a phrase and a practice in its own than guidelines. Does this actually mean quite well for us if we keep placing emphasis on guidelines instead of other options when the manufacturing industry has actually, they have achieved so much success in this using others rather than the guidelines?
Yes, that's a sharp observation, I must say. DFA made the concept is from the manufacturing anyway. Manufacturing has been exploring this for a much longer time than what we do. And actually, the RIBA Rebar actually published a guideline. And for the UCL, actually, he was an RA in my team. So recently we published some papers about the guidelines. Indeed, we focused on a project in mainland China in some rural area. So you have some guidelines indeed, but guidelines are not mutually exclusive with a process, like a systematic process. Okay, you are very right. I think the next step, we probably need to go beyond the guidelines and then produce more followable, specific process, right? Actually, to be honest, I feel actually we lack of best practice examples. And that is why I'm asking my students, You don't tell me the general hollow guidelines or even procedures. You tell me some good examples. You collect some good examples, like for example, DFMA. You tell me, okay, what kind of good practice we can learn. For example, the design for minimizing waste. Now you notice actually people use a lot of long finishing or concrete finishing. Okay, that is actually a very good design for minimizing. So I'm asking my students to develop such kind of a knowledge base, okay, for the big practice. I think different approaches. Top down, so you have guidelines, the process. Bottom up, so you have the processes, and you have the best practices, and then kind of summarized in some process and then guidelines. That's my approach.
Oh, okay. That's very good. Thank you so much. And please just answer the last one. I have a last question regarding tools. I think there are some studies on the DFMA, particularly DFA, dating to 2001, even in construction management. Some tools have been suggested, and I am very much aware that some of those tools are no longer available, and several new ones have been introduced. From a practical perspective, do you know any, powerful tool that has a capability of delivering many of the methods within the design for excellence?
You mentioned it's mainly about design for assembly.
I said I was given like as in some background that these have been available for some time now, and there've been some bespoke tools for DFA or DFM or DFMA, but we have a single tool which is useful for many of the methods within the design for excellence concept.
Okay, I think perhaps there's no single tool. I talked to several designers. Perhaps still we use kind of traditional kind of a checklist or decision matrix method. So basically you have a design option, and then you check this design option against the different criterion like assembly, manufacturing, and then you score, then you evaluate them, and then come up with an optimal one. Yeah, I think it might be too ambitious to have a one-size-fit-for-all design tool for excellence.
Okay, thank you so much.
Okay.
Sir, you can see some more questions. We are just left with 10 more minutes for this session, so you can see them, sir.
Okay, which one would you like? So Wang Chen.
Sir.
Okay, so as we can see, there has been already cooperation in construction industry in first Hong Kong. Okay. Present many strengths in labor and materials. In the meanwhile, there are still some problems in Hong Kong. Lack of labor. Do you think the construction industry in Hong Kong has a tendency to merge with its counterparts in mainland China? If so, what roles precast or we say prefabrication process in this process? Okay, thank you for the question. I think merge perhaps is not. I don't see how you can merge with Hong Kong's construction with mainland China's construction, but exploring the resources in a pool, actually Hong Kong has benefited hugely from mainland China. Yesterday, the two speakers, they all mentioned that the Hong Kong actually cannot stand alone with its own capacity. So I think, late by mainland China's construction backing for the it's obviously the a tendency. Okay, so precast, yes, precast is the way you can think the best way. Okay, so offshore in mainland China and then transport to Hong Kong. So indeed, I don't see how the backlash of globalization construction will look like after. People often say there's a new normal there, but I don't know. Since we are used to the globalization of the supply chain, but now, you know. Okay.
Sure. Maybe a last question from Chi Kong, sir. If you go up.
Chi Kong, yes.
Yes.
In about 2 years later, you're talking about that one? Systemic.
Sir, maybe you have.
Required. Yeah.
Sir, one is this, and one is a little above. One more question is left. Rest all is done.
Yeah, systemic design is required. It may be a challenge to MIC design and construction. Yeah, might be. Although we often say earthquake is less probability thing in Hong Kong, but actually to a certain degree they have considered. And I mentioned they use a steel structure. So and then hinge assemble the units into the main structure. So systemic design has been considered a certain degree in the steel structure, but of course, yes, they need to think more, I believe that. And then up one is any Ji-san Ali.
Sir.
Yeah. So my question is that is prefabrication structurally sound even though it is made with proper design, but it won't be monolithic? Is there any method to make prefabrication construction monolithic? Prefabrication construction monolithic in terms of what? In terms of a structure or all the construction methods?
I think that he was talking about construction at the moment he's not available. So
structure will sound costless as well. The traditional, yes, it's perfect. Structure sound even though it's made with proper design. Actually, we don't have to. We don't have to must go to prefabrication or MIC in the future. Okay, so still, you mean you actually achieve structurally sound design, building quality, cost. All these are considerations. Okay, if you use prefabrication technology in a design DFMA, DFX in a better way in the future, and then that will become dominant. But it's a lateral involvement process, I guess.
I think so. That's it, sir. Then thank you very much. I think there's no more. If any more question, we still have a minute or so.
Yeah.
In this session.
Any other questions? Okay, so if there's any question, you feel free. You can send any further questions to Ifan or to me. All right.
Right, sir. Thank you very much for such an nice and informative presentation. It was really nice sharing. I'm also thankful for all the participants who have spent their time in this to share in this presentation and took part in the weekend. In the near future, we have the next workshop coming up. So I hope and I wish that you will also join us in that workshop. Thank you very much, sir, Professor Wilson, and all the participants. Have a nice weekend. Thank you very much.
Thank you. Thank you, Jeffrey, and thank you to all. Thank you very much. Bye-bye.